In question 1, we're given a scatter plot of the carbon monoxide levels against the volume of traffic in terms of number of cars. And we are told that one point is an outlier and we need to write down the coordinates of this point. Obviously, an outlier is a point that falls outside the pattern, so that's the one here. It's the point with coordinates 100, 18. In part B, we are asked to estimate the carbon monoxide levels when 370 cars pass the point on the road. So to do that, I need to use my scatter plot, and I should be drawing what I deem to be the line of best fit. So we've drawn the line of best fit. We go at 370 cars, and we read off the value from the graph. So it's somewhere here. This is 13.6, the value here. Of course, everyone could have drawn something a bit different, so the examiner is accepting anything between 12.8 and 14.8. We are then told that Alfie says that because there's an outlier, there is no correlation, and we need to say whether Alfie is correct and give a reason for our answer. Now, it is true that there is an outlier, but still the rest of the points are relatively close to a straight line. Hence, we conclude that there is correlation. So the fact that there is one outlier does not mean that there is no correlation. In question 2, Natalie makes potato cakes. She's using potato, cheese, and onion in the ratio of 9 to 2 to 1. She will be making 6,000 grams of potato cakes. And we know that the cheese costs $2.25 for 175 grams. We need to work out the cost of cheese needed to make 6,000 grams of potato cakes. We start by adding 9 and 2 and 1, so it's 12 parts all together. So 2 out of 12 is the amount that the cheese will correspond to. So 2 over 12 times 6,000 is equal to 1,000 grams of cheese needed. Now there are 2 ways to approach this. You could either say that if 2.25 pounds can buy me 175 grams, how many pounds to buy 1,000 grams? So X is 2.25 times 1,000 over 175, which gives an answer of 12 pounds and 86 pence. Alternatively, we can treat it as buying cheese in packets of 175. So 1,000 divided by 175 gives me 5.71 ... So that means we need 6 packs of cheese, and each one is costing 2.25. Therefore, this is giving an answer of 13 pounds 50 pence. In 3, we need to write 4.5 times 10 to the 5 as an ordinary number. So it's 45 and 4 zeros. One was consumed into moving the decimal point 1 place to the right, and the other 4 became 0, so that was the power of 5. Now for 0.007, to be written in standard form, is 7 times 10 to the minus 3. And then to work out this, giving our answer in standard form, I could plug it on the calculator. 4.2 times 10 to the 3 plus 5.3 times 10 squared is equal to 4,730, which in standard form is 4.73 times 10 to the 3. In question 4, we've got a water tank that is empty and can hold 2,400 liters of water. Company A supplying water at 8 liters in 1 minute and 40 seconds, and Company B at a rate of 2.2 gallons per minute. Now, Company A will take more time than Company B to fill this tank, and we need to find how much more time will that be. So starting with Company A, we know that 1 minute and 40 seconds is simply 100 seconds. So we can start by saying that we can supply 8 liters in 100 seconds. So the question is 2,400 liters in how many seconds? So x is 2,400 times 100 over 8, and this gives an answer of 30,000 seconds. Now for company B, we need to make the conversion because we are given the volume in gallons. So 2.2 gallons, each gallon is 4.54 liters. So 2.2 times 4.54 is equal to 9.988 liters. That's every minute or 60 seconds. So 9.988 liters in 60 seconds. So 2,400 liters in how many seconds? So y will be 2,400 times 60 over 9.988, and this turns out to be 14,417 seconds. So the difference between these two is 30,000 minus 14,417, which turns out to be 15,583 seconds. Now the question is asking for an answer to the nearest minute. I divide by 60 and I get 260 minutes as the time requested. So 260 minutes is the final answer. Question 5, it's the first 4 terms of a Fibonacci sequence. Now we know that the rule for Fibonacci sequences is that the new term is the sum of the last two. So a plus 2a is 3a, 2a plus 3a is 5a. So the next term, 3a plus 5a, will be 8a. So we are now looking at the first 5 terms, and the sum of the first 5 terms is 2 to 8, which means that a plus 2a plus 3a plus 5a plus 8a is equal to 228. So 19a is 2 to 8. I divide 228 by 19, and this gives an answer for a, which is 12. In 6, we've got a bag which contains red, blue, green, and pink counters. These are the probabilities for red and blue, and we are in addition told that the probability of taking a green counter is 0.2 more than the probability of taking a pink counter. So if I put an x in the place of pink, then for green it's going to be x plus 0.2, and if I add the probabilities up, 0.05 plus 0.15 plus x plus 0.2 plus x, this should be 1 because the sum of the probabilities is 1. So this leads to 0.4 plus 2x is 1, so 2x is 0.6, which means that x is 0.3. So I can go back to the table. In the place of pink I put 0.3, and in the place of green I put 0.5. Now we've got 18 blue counters in the bag. We need to work out the total number of counters. I will be using the probabilities associated. So for blue it was 0.15. So if a probability of 0.15 corresponds to 18 counters, then the total probability should correspond to the total number of counters. I will call this y. So y will be 1 times 18 over 0.15, which works out to be 120 counters in total. In 7, we need to find the shaded area here. This is simply the area of this sector, which happens to be a quarter of a circle. Take away the area of this right angle triangle. So the shaded area will be the sector, and it's a quarter of a circle. So a quarter pi r square, with the radius being 8, minus the area of the right angle triangle ORP, which is 8 times 8 over 2. Plug everything on the calculator, we'll get 18.3 square centimeters. In question 8, part A, we need to sketch a graph representing y being directly proportional to x, we know that this should be a straight line, and in addition it should pass through the origin. So we're looking for a straight line that passes through the origin. And then in part B, we need to show inverse proportion. So this will be a reciprocal graph that looks something like this. So as x becomes progressively larger, then y drops, and similarly as x becomes smaller, y increases. In 9, we know that 12 people took 5 hours to clean a number of cars, and on Tuesday we've got 15 people cleaning the same number of cars. We need to work out how many hours these 15 people took, assuming that they all worked at the same rate. So this is an example of inverse proportion, because the more people you have, the less time it takes to finish the job. So the product in inverse proportion is always the same. So 12 times 5 is 15 times x, where x is the number of hours. So 60 is 15x. I divide by 15, it gives a value of x of 4, so they will be needing 4 hours. Now we are told that the assumption is wrong, and we are asked how might this affect the time taken for the 15 people to clean the cars. Now it's obvious that if people do not work at the same rate, then it is possible that we might take either more than 4 hours or less than 4 hours to clean the cars. So we could say that they could take more or less than 4 hours to clean the cars. In 10, we've got two right-angled triangles here. It's triangle ACB and triangle DEB. We are told that AD is 9 centimeters, DE is 2 centimeters, and DB is 6 centimeters, and we need to work out the length of CB here. I could actually draw out the two triangles that are similar here. It's triangle DEB and ACB, and I will add the information on these individual triangles. DB is 6 and DE is 2, and then we know that the length AB is 15, and we're trying to work out the length of CB. Now I will start by using the proportionality to find AC. So if I call AC x, then we can say that if 6 becomes 15, then 2 becomes x. So the corresponding sides are the DB with the AB and the DE with the AC. So 6x is 30, and therefore x is 5. So now that we've got that AC is 5, I could use Pythagoras theorem and say 5 squared plus CB squared is 15 squared. So 25 plus CB squared is 225, which means that CB squared is 200, and therefore CB is the square root of 200, which works out to be 14.14. We have been told to give our answer correct to 2 decimal places. In 11, Freya writes down the value of x correct to 1 decimal place. She got 6.4, so she could be anywhere between 6.45 and 6.35, because any value within this interval will round to 6.4 correct to 1 decimal place, and therefore this is the error interval for x. In 12, we are asked to work out the value of a and n in this expression. So we can start by saying that ax to the 6 raised to the 1 over n can be written as a to the 1 over n times x to the 6 over n. Remember that when I raise a power to a power, I multiply the powers together, the indices. And we are told that this is equal to 7x cubed. So this means that x to the power of 6n is x cubed, and a to the power of 1 over n is 7. So I start by considering the x term. the base is the same, it's x, so 6 over n is equal to 3. 6 is 3n, so 2 is n. So a to the 1 over n is 7. We just found that n is 2, so a to the 1 over 2 is 7, which means that a is 7 squared, which is 49, and therefore a is 49 and n is 2. But in 13, we've got a pattern made from 4 identical rectangles. We start at A with coordinates 3, 4. We end up at B, 11, 20, and we need to work out the coordinates of C. Well, it makes sense to call the length x and the height y. So this is also x, this is also x, and this is also x. And then the small parts are y. And I will try to form equations involving x and y. If we consider the horizontal movement, it's going to be x and another x and then minus y, because I come back to go from 3 to 11. So as a starting point, 3 plus x minus y is 11, which leads to 2x minus y is equal to 8. And then I will do the same with the vertical movement. From A, I will go y plus x to move from 4 to 20. So I get that 4 plus y plus x is 20, which simplifies to 2x plus y is equal to 16. So we're now looking at simultaneous linear equations. I could add the two equations, so 1 plus 2 will give me that 4x is equal to 24, and therefore x is 6. So 2 times 6, I substitute into the second equation. For example, 2 times 6 plus y is 16. So 12 plus y is 16, which means that y is 4. So to go from point A to point C, I will have to go 6 units to the right and then 4 units up, which takes me to 9,8. These are the coordinates of the point C. In 14, Olivia and Jessica have in total half as many sweets as Fran and Gary. Now Fran and Gary share in the ratio 2 to 3. Olivia and Jessica share in the ratio 9 to 1. And they end up with W, X, Y, and Z sweets respectively, and we need to find in its simplest form this ratio. So I will start by writing the names. It's Fran, it's Gary, then Olivia, and Jessica. I will put the original ratios given here. So Fran to Gary is 2 to 3, and Olivia to Jessica is 9 to 1. As they stand, we've got 5 parts in total for Fran and Gary and 10 parts in total for Olivia and Jessica. Now we need to take into account the fact that Olivia and Jessica have half as many sweets as Fran and Gary, or if you want to see it from the side of Fran and Gary, they should have double of what Olivia and Jessica have. So I would like this to be a total of 20 and these to remain a total of 10, so that I enforce somehow this relationship between the total of Olivia and Jessica and the total of Fran and Gary. So to go to 20, I need to be multiplying by 4. So this gives me 8 and this gives me 12. This remains as 9 and 1. And therefore we can conclude that W to X to Y to Z is simply 8 to 12 to 9 to 1. In question 15, we have the graph of the volume of water in liters in a container t seconds after it started flowing out of this container, and we are asked to work out an estimate for the rate at which the water is flowing out when t is 12. So when t is 12, we are here. So to work out the rate, this means we need to draw the tangent at this point. This should be a line that touches this point. Obviously, everyone is drawing something similar, yet not identical. So if we draw our tangent, it looks something like this. And to work out the rate, This simply means we need to pick 2 points on the line, and based on that, we find the gradient. So it's easy to see that we pass through the point here, 29, 0, and the cut on the y-axis is at 28.5. So the 2 points I'll be using are 0,28.5 and 29,0. So I'm using m is y2 minus y1 over x2 minus x1, which turns out to be 0 minus 28.5 over 29 minus 0. To 3 significant figures, it's minus 0.983. So the rate at which the water is flowing out is 0.983. We do not include the negative sign. It's incorporated in the expression flowing out. And it's worth noting that the examiner here is accepting anything from 0.7 up to 1.1. In 16, we need to show that the curve C and the straight line L have exactly 1 point in common. So one hand we've got y is x squared plus 3x minus 3, and on the other hand it's the straight line with the equation y is 5x minus 4. I equate the two to get x squared plus 3x minus 3 is 5x minus 4. And then I will be collecting everything on the left hand side. So x squared minus 2x plus 1 is 0. This factorizes into x minus 1 all squared being 0. So x minus 1 is 0, which means that x is 1. So we have only one solution, and here there's exactly 1 point in common as required. In 17, we've got that x is directly proportional to the square of y. So we've got that x is proportional to y squared, which means that x is k1 times y squared for some constant k1. And similarly, y is directly proportional to the cube of z. So y is k2z cubed. In addition, we know that when z is 2x is 32, and we need to find a formula for x in terms of z. I need to find a way of combining these two together, so it makes sense to say that y squared is k2 squared times z to the power of 6. I've raised everything to the power of 2, and therefore I will be replacing y squared with k2 squared z to the power of 6 to obtain that x is k1 times k2 squared times z to the power of 6. The k1 times k2 all squared is simply another constant which I will call k, and therefore we have that x is kz to the power of 6. Now when z is 2, x is 32, I will substitute this, so 32 is k times 2 to the power of 6. 32 is 64k, so 32 over 64 is the value of k, which works out to be a half, and therefore my final answer will be that x is a half z to the power of 6. Question 18, it's a vector question. We are being told that OA is A, AB is B, and OC is 3B. In addition, OD to DB is 2 to 3, and BE to EC is 1 to 4, and we need to find the vector DE in terms of A and B. We need to give our answer in its simplest form. So DE is gonna be DB plus BE. So I'm saying that to go from D to E, I can go from D to B and then from B to E. Now DB is 3/5 of OB, because if we look at the ratios, the DB is 3 parts and the OB is 5 parts, and they go in the same direction. So DB is 3/5 of OB, and similarly BE will be 1/5 of BC. So plus 1/5 BC. Now OB, to go from O to B, we can go back to the diagram. OB is simply A plus b. So I start replacing the vectors with a and b, and going from b to c, we can say it's minus b minus a because I'm moving in the opposite direction, plus 3b. So it's going to be minus b minus a plus 3b. I expand the first bracket, it's 3/5 a plus 3/5 b. And for the second bracket, I collect the like terms, so it's 1/5 of 2b minus a. So a further expansion will take me to 3/5 a plus 3/5 b plus 2/5 b minus 1/5 a. And therefore, as a final answer, the vector DE is 2/5 of a plus b. In 19, we've got this relationship for the number of animals in the population, Pn, that's in year n. So to go to the next year's population, we multiply the previous year population by k. We know that in 2017, we had 4,000 animals in the population. So in the next year, we multiply by k. And if we multiply again by k, we get 4,000 k squared, and we have been told that this is 3,610. We're trying to find k, so k squared is 3,610 over 4,000, which means I can take the square root of this number, 3,610 over 4,000, and this gives an answer for k, which is 19 over 20, or 0.95. In 20, we are told that Pat throws a fair coin n times, and we need to find an expression in terms of n for the probability that Pat gets at least a head and at least a tail. So first of all, the fact that the coin is fair means that the head and the tail are equally likely. They have a chance of a half of appearing at each toss, at each throw. We know that we are throwing this n times, and in order for us to get at least one head and at least one tail, we can think of this as 1 minus the probability of all heads or all tails. So you can split the whole possibility space into either everything being heads, all being tails, or having at least one head and at least one tail. Now this is crucial in order for us to get an expression for the probability required in terms of n. Now the probability of getting all heads is a half to the n because each throw has a probability of a half of resulting to heads, and similarly a half to the n for resulting into everything being tails. Now I've got addition of a half to the n plus a half to the n, so it's 1 minus 2 times a half to the n. Strictly speaking, I could stop here because I have not been told to give a simplified expression, so this is an expression in terms of n. However, if I want to proceed in simplifying this, I could write this as 1 minus 2 over 2 to the n, which is simply 1 minus 1 over 2 to the n minus 1. In 21, we've got a speed time graph, and we are asked to use 3 trapeziums of equal width to work out an estimate for the area between t is 1 and t is 4. So I will start by drawing vertical lines at 1, 2, 3, and 4, and I could actually join these lines together to form a total of 3 trapezia here. And we know that if we calculate the areas of the 3 trapezia at the map, then we will be getting an estimate for the area under the graph between t is 1 and t is 4. I start by identifying the heights, so it's 4, it's 6, it's 7.2, and then it's 7.8. So the area, I will be using the formula for the area of a trapezium, so it's base 1 plus base 2. It's worth noting that the bases are the y values. The height of each trapezium is simply 1, and it's the same for all trapezia. So it's 4 plus 6 over 2 times 1 base, 1 plus base 2 over 2 times height, plus 6 plus 7.2 over 2 times 1, plus 7.2 plus 7.8 over 2 times 1, and this is giving an answer of 19.1. In part B, we need to say what does this area represent. Well, we know that the area under a speed-time graph is the distance covered. If you think about it, speed is distance over time. So if I rearrange this and I multiply speed with time, then I'm getting distance, and essentially finding the area involves multiplying speed with time. So this is the distance covered. In 22, we are given these algebraic fractions and we need to combine them together into this form. So we start with 6x cubed over 9x squared minus 144 divided by 2x to the power of 4 over 3 brackets x minus 4. So I start by factoring out the 9 in the first denominator to give me 9 brackets x squared minus 16. And we know that when we've got division with fractions, we flip the second fraction and we move into multiplication. So it's going to be 3 times x minus 4 over 2x to the power of 4. Now we have some simplifications here. The 6 with the 2 leaves me a 3 here, and then the 3 with the 3 and the 9 all go away. In addition, the x cubed with the x to the power of 4 leaves me x. So in the numerator, we've got x minus 4. In the denominator, we've got x, and then the x squared minus 16 is the difference of two squares, x minus 4, x plus 4. So this can go away, and I'm left with 1 over x brackets x plus 4, which matches the form of the required answer. In 23, we are being given triangle ABC, and given that these two angles are of the same size, we need to prove that AB over BD is AC over DC. So in order to do that, I will employ the sine rule. I will start by calling the angle here at ADC phi, and this here is obviously 180 minus phi. So if I consider triangle ABD, then we can see that sine of x over BD is equal to sine over 180 minus phi over the AB. Now similarly, I could consider the triangle ADC, and in this case I get that sine x over DC is equal to sine of phi over AC. Now I have to use another rule here. It's the rule that says that sine of phi and sine of 180 minus phi are the same. Essentially what we're saying here is that two angles that up to 180 have the same sine. So I could replace this saying sine x over BD is equal to sine phi over AB. So this means I could now say that AB sine x is BD sine phi, and therefore we get that AB over BD is sine phi over sine x. And I will proceed in a similar fashion here to get another expression for sine phi over sine x. So AC sine x is equal to DC sine phi, and therefore AC over DC is sine phi over sine x. Notice that we've got two expressions, both of which are equal to sine phi over sine x, and therefore we can say that AB over BD is equal to AC over DC, which is exactly what we had to show.